Kyotaba mfana boss, so halala right now. Good day, grade 11s. Remember that in our previous session we were talking about the kinetic molecular theory. That's just what we were talking about. We even went to University of Colorado. We took a plane to University of Colorado, USA, Denver, trying to see the particles and how they move. Remember that chemistry is the study of composition of matter, the study of the structure of matter at a macroscopic level, microscopic level, and symbolic level. Now, we couldn't see, of course, at a microscopic level as to what is happening to particles, but thanks to Denver, thanks to University of Colorado, we saw the talala right now. So according to the examination guidelines, we cannot go to that physical sciences examination, of course, without having the ability to describe the motion of individual gas molecules. We have to understand that molecules are in constant motion, and we saw that this constant motion led to the collision of particles between themselves, led to the collisions of the particles in the container. So we saw that from the University of Colorado. And we recognized and realized that there are forces of attraction between the molecules. We saw that mostly during liquefaction. That sounds scary, mfanabo. So this, of course, it was when now we started with a gas, and we said, what if then we start with a gas? And what do we do to the gas? We obviously put it under low temperature. We decrease the temperature of the gas, and we try to see what is happening to the average kinetic energy, what is happening to the motion of the particles. And of course, we've realized that molecules in a gas move at different speeds. That's what we've realized. But those gases that we were talking of and about at that particular time and moment was specifically for the real gases. That is what we were talking of and about at that time and moment. The real gases that we know of and about. Why bonataba mfanaboso? Halala right now. Now mfanaboso, we want to introduce ourselves to what we call ideal gases, because the examination guidelines, of course, says that we must know what are ideal gases. The examination guidelines says that you must go to that physical sciences examination, specifically chemistry paper 2, knowing how to describe an ideal gas. Of course, describing an ideal gas, of course, as having identical particles of zero volume. That sounds weird. We'll try to explore that to try to understand what does it mean when we say zero volume. That sounds weird. We'll explore that in Fanabo also. We are going to realize and recognize that then for these ideal gases, there are no intermolecular forces between particles, which is weird because when we were talking about real gases, we mentioned the issue around attraction forces between molecules. But as for the ideal gases, unfortunately, that is not the case. Here, there are no intermolecular forces between the particles in Fanabo. So, halala right now. Now, what we also recognize is that ideal gases are gases in which all collisions of molecules with themselves or the walls of the container are perfectly elastic. So we'll try to explore that concept there to say, holy shit, what do we mean when we talk about the concept elastic? So, in order for us to be able to understand the ideal gases, we must of course understand our real gases. So if we have an understanding of the real gases, perhaps according to the kinetic molecular theory, therefore we will have the ability then to understand the ideal gases or the hypothetical gases, so we say. Why bonataba mfanabo so halala right now. Now, what we've recognized and realized about real gases is that they occupy a particular volume, whereas these ideal gas, we say they occupy no volume at all. Syringe, and you put your finger there at the front of it. What is going to happen is that as you push it more and more, it's going to come to a point whereby you can't push it any further. That is because there is a particular set of volume that the gas can occupy. There is a particular set volume that the gas can occupy, But with ideal gases, well, if we were to pinch the syringe, we would pinch the syringe forever and ever. And unfortunately, because there is no volume that is occupied here by these ideal gases, therefore we say they occupy no volume. Now, the other thing that we've discussed was when we were talking about the issue around decreasing the temperature within real gases. When we decreased the temperature of real gases, we saw that they started to liquefy. That is because there are intermolecular forces. We have forced the particles to come closer together, and that way we saw then liquefaction happening. But for the ideal gases, unfortunately, that's not the case in Mfanabo. So here, even if we can decrease the temperature as much as we want, there is no liquefaction at all here. No liquefaction at all. It's not possible. That is because there are no intermolecular forces between the particles in Mfanabo. So, halala right now. As we saw from the examination guidelines, we have mentioned to say, well, when we talk about these ideal gases, it is necessary to mention that the collisions, of course, are elastic. Now, we said we will explore as to what does the concept elastic even mean. The concept elastic simply means there is no energy lost. There is no energy lost here. That is why we talk about the concept elastic. So, however, for the real gases, we will see a bit of loss of energy from the collisions. That is because there we're talking about inelastic collisions in which energy can be lost somehow. We saw the particles were colliding, but the more we decreased the temperature, the more energy was lost. So we say then the collisions are inelastic for the real gases. So halala right now. Now, the other thing that we want to mention about the real gases versus the ideal gases is to then say that for the ideal gases, the particles move at the same speed. That's what we say. Remember that after all, the ideal gases are just hypothetical. That's a scary term. You must balance yourself a bit before you pronounce it. So when we talk about the concept ideal, we are talking about hypothetical. Think of it as being fake gases. Why not? If we have real gases, we can therefore think of ideal gases as somehow non-existent gases, fake gases, so we can say. Please don't say that in the examination. Now, we have to understand that in actual fact the particles move at the same speed for the ideal gases, whereas of course the particles move at different speeds for the original real gases. So for real gases, we saw that from the kinetic molecular theory that some particles were faster and some particles were relatively slower, but there was motion, of course, of particles. So what we are saying then is that in order for us to understand the ideal gases honestly, it takes us some effort. It will take us some effort, which will be to also understand what are real gases. Hence, we started by exploring the University of Colorado's FET simulations, whereby we were talking about the states of matter and the kinetic molecular theory. So these real gases, they can behave like ideal gases. So it's more like we are using real gases to sort of model ideal gases. So what we are saying therefore is that between the ideal gases and the real gases, they can somehow behave the same but under certain condition. So these two, which is the ideal gases versus the real gases, they can behave the same under particular conditions. However, they can also behave differently. That means their behavior can deviate, and we have to, as chemists, understand as to when do real gases and ideal gases behave the same, when is their behavior deviating, when is their behavior different. So we are going to explore then as to when do they behave the same, when is their behavior deviating ngoba bazobuza nge-exam mfana boss. So njalo nje halala right now. Mfana boss, so remember that analogy of a syringe. Take that syringe, put a finger, and then of course try to squish it, or whatever English is saying there, try to squeeze it, something like that. I don't know if that's the correct terminology, but try to push it. What is going to happen is that it is going to be pushable, yes, because that is a real gas, but there's going to come a time whereby now it will be either hard or impossible to push. Impossible in such that the syringe may even fracture, it may explode somehow if we put more and more pressure. So that is what we learn here about the real and the ideal gases, to say, well, their behavior may be different, for instance, at that particular instance. So at that particular instance, when you push the syringe, you are decreasing the volume. And as you decrease the volume, there is little space for the particles to run around. Remember, gas particles are always in a rush. So there is little space when there is little volume for them to run around. That means there is higher pressure. So since there is higher pressure, then that's whereby we can now say, well, there is a difference in terms of what? In terms of the behavior of ideal gases and real gases at that particular condition, at high pressure. At high pressure, the ideal gases start to do what? The ideal pressure, or rather the ideal gas and real gases, they start to act differently. Their behavior starts to deviate. That's what we are saying here, Fanabo. So, halala right now. So also, if you recall, at low temperatures, we said that, well, at low temperatures, as we decrease the temperature more and more for real gases, they can liquefy. But for the ideal gases, of course, there is no liquefaction. So it means, therefore, they behave differently at that particular condition. So you must know this by heart and soul. Halala right now. They will say, explain when is the behavior of real gases and ideal gases deviating. You must know that is at high pressure and low temperature, and you must give reasons behind why is that the case. Why bonata? Last but not least, of course, we must be able to state the conditions under which the real gas approaches ideal gas behavior. That is to say, when is their behavior the same? Of course, their behavior will be the same at low pressures and high temperatures. At high temperatures, low pressures, definitely the behavior of gas particles or real gases will be the same as that of ideal gases. Mfana Boso, my name is Mr. Majaki Sanese. They call me Mr. M. Mfana Boso. In the next section, we will of course try an activity, of course, on ideal and real gases. And of course, we will continue now with the gas laws. Mfana Boso. I'm here for you, of course, to ensure that you enjoy learning, you love learning. That's what I'm trying to do here in Fanabo. So please try to subscribe. It costs 0 cents. All it will do, it will cost you perhaps 1 second of your time. Please hit that subscribe button, and of course not only the subscribe button, but of course also the notification bell, so that every time I upload, you'll be notified. At least now I know the language that these people use. Halala right now. Thank you very much for those who've watched and those who've subscribed. Thank you very, very much. So welcome to Science Intellect Hub.